Hi guys, in this episode of Shri series, we're going to be talking about index laws and a few other rules that we're going to be using. Alright, now if you looked at my previous videos, we looked at certain laws, index law number 1, index law number 2, and then we looked at some questions involving those laws. Alright, so I just thought we use this time to look and review at the previous laws that we talked about. Alright, so if you look at the first law, we refer to it as your addition law. All right, and if you remember this, the formula goes like, if you've got a to the power m times a to the power n, all you simply do is just add the powers. All right, I gave an example, say for instance, a to the power 4 times a to the power 3, that becomes a to the power 4 plus 3, which is a to the power 7. All right, so that was a simple example of the addition law. Now, if we recap the second law that we talked about, so this is the subtraction law or the division law. So let's look at the subtraction law. All right, and what does that simply state? All right, so it's the opposite. All right, suppose you've got, say for instance, a to the power m divided by a to the power n. You can express this as a to the power m over a to the power n. That's the same as a to the power m minus n. All right, so that's the law of division, where you simply subtract the powers. All right, a simple example, let's say you've got a to the power 8 divided by a to the power 2. That's going to be a to the power 8 minus 2, which eventually becomes a to the power 6. All right, so these are examples of basic laws that we talked about in my previous video, which was Introduction to Index Laws Part 1. All right, now let's look at two other important laws. All right, and then we look at some worked examples. All right, so let's look at a situation where you've got a power and they're in brackets. Okay, so let me illustrate what I just said. Okay, suppose you've got, say, a to the power m brackets and the whole thing to the power n. How do we interpret this? All right, so a to the power m, the whole thing, brackets n. What is that equal to? All right, so all you simply do is you say that's a to the power m times n, and that becomes a to the power m n. So literally what you need to do is multiply the power in the bracket, that's the m, and the power out of the bracket, which is n, and you're going to get a to the power mn. All right, now let me give you a simple example to illustrate this. Suppose for instance you've got, say, a to the power 4, the whole thing to the power 3. That now becomes a to the power 4 times 3, which is a to the power 12. All right, so that's what you're literally doing. So you get the power inside, multiply by the power outside, and you're going to get a to the power 12. All right, another simple example. All right, so let's say we take that out, and suppose we do a little bit more complex. All right, say for instance you've got 2y 5 to the power 5, the whole thing to the power 3. How do we work that out? All right, now we know very well, we know what to do with the y, because y to the power 5, the whole brackets to the power 3 becomes y to the power 5 times 3. So we know what we do here. We've got y, which is 5 times 3, which is y to the power 15. All right, but you got to remember that there's also a 2 there. All right, so we've got to deal with 2 to the power 3. So what that now becomes is, use a different color, that would be 2 to the power 3. Why? Because you've got that 2 and to the power 3, which is the same as 2 times 2 times 2, and that becomes 8. So your answer eventually becomes 8y to the power 15. All right, so you can see with this question, just like I'd said before, when you're working on calculations involving index laws, you're not only dealing with numbers, but you're also dealing with letters. So if you look at 2y to the power 5, you've got a number and a letter, and then you've got to work out how we apply those laws. All right, so 2y to the power 5 is 2 to the power 3, which is 8, and y to the power 5 cube is 5 times 3, and we combine them together and you're going to get 8y to the power 15. All right, so that is, I would say, law number 3. Now different textbooks have different numbers for these laws. All right, I'm just progressively going from first down in order of how we can work through and complexity wise. All right, now having looked at this rule, let's look at the other rule. All right, now I personally feel this is the easiest rule, which is the power 0 rule. All right, so anything to the power 0 is equal to 1. All right, so let's say, for instance, I write that again. So that's rule number 4. And what rule number 4 simply states is, imagine you've got a base, all right, and it's got a power 0. What does that equal to? That equals to 1. So what that states is anything to the power 0 is equal to 1. All right, suppose you've got 100 to the power 0, that'll also be equal to 1. 1000 to the power 0 is equal to 1. All right, so anything to the power 0 is equal to 1, and that is what the rule talks about. Okay, so let's look at some problems that apply this rule. All right, so let's say, for instance, I pick two simple questions. For instance, let's say you've got 4a to the power 0. What is that equal to? All right, now we know very well a to the power 0 is equal to 1. So what we do is that's 4, and then I put bracket 1 just to show you that a to the power 0 is equal to 1, and 4 times 1 equals to 4. All right, so that's a pretty straightforward problem to work using the rule of 0. All right, suppose you've got another problem. All right, let me just let's say right here, there's a bit of space here. Say, for instance, we've got 2p to the power 0 plus 3p all brackets to the power 0. All right, what does that mean? Okay, now you got to look at this very, very carefully, because 2p to the power 0 and 3p to the power 0 are interpreted differently. If you look at 3p to the power 0, the whole 3p is in a bracket. Whereas if you look at 2p to the power 0, p is connected to 0, all right? So they're all not in a bracket. So if you look at 3p to the power 0, that automatically becomes 1 because anything to the power 0 is 1. And if you look at p to the power 0, that's 1, and you multiply by 2. So that becomes 2 plus 1, which is 3. All right, so it's very important to interpret questions involving the power 0, because if I look at 2p to the power 0, that's p to the power 0, that's 1, and I multiply that with 2. Whereas if you look at this one here, you've got 3p all in brackets, so that as a whole to the power 0 becomes 1. And when you add them together, you are going to get 3 as your answer. All right, so that's how we work through index laws. All right, obviously the law number 3 that we talked about is am. The whole thing to the power n is actually a to the power mn. All right, and then the fourth law is the power 0, because anything to the power 0 is equal to 1. All right, in the next set of videos, we're going to be solving problems that involve the whole set of rules in there. All right, we will also be talking about the negative power and how we can deal with complex questions involving the negative powers and how we can simplify to solve them. All right, thanks for listening, guys. Bye now.